Assalamu alaikum. Welcome to lecture number 6 of the Advanced Information Systems course. In the last lecture we started vector space model. Today we will continue the vector space model inshallah for ranking of documents for any given query, and the second topic we'll talk today is evaluation of IR methods inshallah. So in the last lecture we discussed vector space model in which every document is represented as a vector and a query is also represented as a vector, and the similarity between the given documents and the given query can be calculated with this simple math. In the last lecture we have learned how to develop a document vector. Okay, so today we'll see how to calculate the magnitude of a vector by using this formula. Okay, we'll just take sum of square of all the components and take square root of it. Then we'll do the same process for the given query. We will calculate the query vector and we will calculate the magnitude of the query vector, and then we will multiply both of them to calculate the similarity between a given document and a query. So this is what we are going to do. Very simple process. This is where we had stopped in the last lecture. We calculated the vectors of all the documents in the document collection. So now we want to calculate the magnitude of each vector. We will calculate magnitude of D1, D2, D3, D4 and D5, and we will divide the vectors by this magnitude to calculate D by D mod. So let's talk about document D1. So we'll apply the same formula, take sum of square of all the components and take the square root. So here we have three terms in this document. We have 1.32, we have another 1.32, sorry, four terms, 1.32 and 1.32. So take square of each one of them, add them together and take the square root, and you will get the mod of this document. So we take 1.32 square plus 1.32 square plus 0.32 square plus 1.32 square. So this is, we get the length of the document, or we call it D1 mod. Okay, this is the length of the document. In the next step, now we divide the entire vector by this document length. So D1 by D1 mod. So if you recall, the first component was 1.32. Okay, so we take 1.32 and divide it by the mod, which was 2.308. 2.308. Similarly, we take this 1.32 and divide it by 2.308. Similarly, this one. We divide all of them by the length of the document vector, which is 2.308, and we get this. We get 0.57, we get 0.7, we get 5.57, 0.14, and 0.57. Right? Similarly, we will have calculated the vector for document D2, D3, D4 and D5, and now we calculate the mod and we divide them. So we have normalized these vectors by their length, right? So these are normalized vectors for all the documents in the document collection. Now next, if we wish to rank these 5 documents with respect to the query query sir. Now this is a given query. Let's say we want to calculate the similarity of this given query with all these documents, now what we need to do, we need, first of all, we construct query vector and normalize by length. So in the first step, we develop query vector and then we normalize it by length. The idea is process this query vector, process this query as any given document in the document collection. So whatever we have done for all these documents, we will do the same for the given query, right? So if you remember in the last lecture we discussed, first of all we calculated TF IDF score for do, then we calculated TF IDF for you, then for quirl, then for sir, and then we put it in a uniform format for all the components in the vocabulary of the entire document collection. So now we'll do the same for the given query. We will calculate TF IDF score for quirl. Okay, so TF IDF score for quirl. I hope you remember the formula. TF. So first of all, log of frequency of term T in document D. So quirl, it appears only one time in this query, so it will be log of 1 plus 1. Okay. In a query, we might have repetition of the same term. So let's say if my query was quirl sir quirl. So now the frequency of quirl in this query in this document is 2, quirl sir quirl. Or maybe we had sir appearing 2 times, sir quirl sir. So in that case, the frequency of sir in this document is 2, right? So mostly in the queries, the frequency of every term is 1, mostly. But if it is more than 1, then we will put it over here. Okay. So here, log of 1 plus 1, this is TF. Okay. We multiply it with IDF. Now IDF for quirl, you must have already calculated in the document collection while preparing these vectors. So when you prepared these vectors, you calculated IDF for a, you calculated IDF for am, you calculated for as, for bear, and so on and so forth. Now you will use the same IDF value in the query. Please remember, you will use the same IDF value in constructing the query vector that you have already calculated in the previous step, right? So when calculating the IDF for quirl in this document collection, how could I do that? What I will do, I will take log of n, which is 5, and in how many documents the term quirl appears. If it appears in document 1, document 2, and that's it. So it is 5 over 2, right? So this is IDF value for quirl that you have already calculated in the previous step while developing the query vectors. We use the same value. So now we multiply TF by IDF, we get this value. I think probably you will get this as 1.32. Okay, so for quirl you will get 1.32. For sir, you will use the same method. The frequency of sir in this document is 1. So log of 1 plus 1 into IDF value of sir that we had already calculated. So this is 0, and this will come out to be 0.32. And we have zeros in all the other places. Okay, so in this query vector, we will have 0 for a, for am, for as, bear, do, for, up to quirl. So all these components will be 0. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there are 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I have a value for quirl. Then the next is serve, serve 0, sir, serve is 0. Then this is for sir, and I have two more terms after this. So this is the query vector. This is Q. Okay, this is Q. Then you calculate Q mod. How you can calculate it? Simply take sum of square of all the components and take square root. So it is 1.32 square plus 0.32 square root. You'll get a value. Okay. So now you divide this value by both these components and you will get 0.97 and 0.24. Okay. Probably I think you get something like 1.36. Now you divide 1.32 by 1.36, you will get 0.97, and you divide 0.32 by 1.36, you will get 0.24. Okay. So now we have developed the query vector and normalized it by its length. We have calculated Q by Q mod. All right. I hope you can repeat the process by yourself. So we have considered query as any document in the document collection. We applied TF, IDF on each one of the terms. IDF, you can take the same value that you have calculated in the entire document collection, use the same value, calculate the query vector, then calculate the length of the document, okay, divide it, and now we have got the query vector. Now in the next phase, now we have this query vector, we have document vectors, we want to calculate the similarity of the query with all the documents to rank them in the order of relevance with the query. So in the last lecture we had discussed this simple formula that if we want to compare, if we want to calculate the similarity between a document and a query, we calculate d by d mod and we multiply it by q mod. So now we have calculated d by d mod for all the documents. Okay, you can see d by d mod for all the documents, and we also have got q by q mod. So now very simple, you just multiply query with each one of the documents, okay, to calculate the similarity. Okay, for example, the similarity of document D1 with the query is calculated like this. What we have done, we have this component for query, this component for sir. In document D1, this is the component for query and this is the component for sir. So just multiply 0.97 by 0.57, multiply 0.24 by 0.14, add them up and you get the square, you get the value. So this is the similarity value between query Q and document D1. Similarly, you can calculate the similarity of query with document D2. So in document D2, the value for query is 0.67. So multiply it by 0.97. Similarly, the value of sir is 0.33, multiply it by 0.24 and you will get similarity of document 2 with the query. Okay. In document 3, the value of query is 0, so you can ignore it. You simply multiply 0.03 with 0.24 and that is the similarity of Q with this document. So you keep repeating this process for all the documents and these are the final values that you get. So document 1's similarity with the query is 0.59. The similarity of document 2 with the given query is 0.73. The similarity of document 3 is 0.01. For document 4, it is 0.00. Why? Because in document 4, the value for query and sir, this one, document number 4. For document number 4, the component of query and sir both are 0. Okay, that's pretty obvious. In document 4, we do not have these both these terms, query and sir, right? So there it's 0. In document 5, it's 0.03, right? So if you want to rank which document is the most relevant to the query, it is document number 2. because the value of 2 is the highest among all the documents. What is the number 2? The second most relevant document is document 1, because this value is less than 0.73. Similarly, document 5 is lesser, document 3, and document 4 is completely irrelevant. It is the least relevant to the query. So this is the rank of the documents with the given query. Okay, this is how we apply vector space model on the documents and the query to calculate similarity of the documents with the given query. The last topic in our information retrieval methods is the evaluation. We have discussed in the first lectures that for evaluation there are two kinds of measures. First are the objective measures or the numeric measures we talked about: throughput, response time, the carbon footprint, those things. They can be measured quite easily. They are the objective measures. They deal with numbers. The second we discussed in the previous lectures was the qualitative measures or the effectiveness of the search results. And the effectiveness, it depends on human judgment. So we discussed several challenges in the last lectures that human assessment of relevance, it is quite subjective. The same result for a given query may be relevant for me, it may not be relevant for you. It may be relevant for me now, it may not be relevant for me after 1 hour when I have got more information. So there are many challenges in measuring the effectiveness of the search results. In some cases, it might be possible to infer these assessments implicitly from user behavior. Sometimes the user behavior can also guide you whether the results are relevant for the user or not. Let's say our IR system returns the results to the user and they do not spend any time on those results. It means they are not effective for them. They went to the pages and they quickly close them. Or maybe the page remains open for a long time. The user really reads it. He scrolls through the entire document. It means the page was relevant. So there are user behaviors from which you can make judgment, but most published IR experiments, they are based on manual assessment of the results that is created explicitly for experimental purposes. So we have huge document corpuses available online. Some references are available in the book chapter that I've already shared with you. So we use these available data and we get manual assessment from the users to measure the effectiveness of the IR methods. So let's say you develop a new IR method for ranking for relevance of the documents. Now you can measure the effectiveness of your newly developed algorithm with the corpus that is available, and then the people, they can evaluate whether your documents, they are actually relevant to the given query or not. So mostly this process is done manually. The people will manually assess your query with the results provided by our IR system. These assessments are often binary, and assessor reads the documents and judges it relevant or not. So a person will read the document and then he or she can say, can answer in binary like yes or no. Okay, we can have a binary answer like this document is relevant or not. We can have binary evaluation. In order to determine the effectiveness of a Boolean query such as this one, we compare two sets. We can have a graded evaluation as well. Here we are talking about Boolean or binary evaluation. The document is relevant or not. We may have a graded relevance, like this document is extremely relevant to somewhat relevant, relevant, not relevant, or completely irrelevant. Let's talk about the binary evaluation. So when the user says it is relevant or not, the binary yes or no, Then we compare two sets. The set of documents returned by the query, we call it result set, and the set of relevant documents in the topic collection, we call it the relevant set. So result set is the set of documents that are returned by the algorithm that you have developed, okay, and the relevant set is actually the set of documents which are really relevant to that topic. So of course no method gives 100% performance, so ideally the result set should be exactly equal to the relevant set. If this is the case, it means your results are 100% accurate. Okay, it means you return all the documents which are actually relevant, no more, no less, right? But in reality, in actual cases, the result set will contain some of the irrelevant documents. So in the result set, if this is a result set, okay, it may contain some irrelevant. So there are some relevant and some documents which are not relevant, okay, and some relevant documents, they may lie outside it. So it may ignore certain relevant documents and it may include certain irrelevant documents. So this is the result set. We'll see it graphically in the next slides as well. So there are two basic measures for IR effectiveness. One, we call it the recall measure. Recall indicates a fraction of relevant documents that appear in the result set. Okay, so the common between result set and the relevant set divided by the relevant set, you get the recall. In fact, this is mod. These are the numbers. So how many documents they are common in the relevant and the result set, and how many documents are actually relevant, you divide them and you get what we call as recall. And similarly, precision is the ratio between the result set that is relevant. So you compare the same ratio with the result set. Here it is with the relevant set. Probably it will not be very clear for you. To make it very clear for you, I have taken this image, this graphic from Wikipedia. So here in this diagram, you can see all the documents over here. This is all the documents in the document collection. For any given query, some documents are actually relevant and some are irrelevant. So this one, these are the relevant elements. Okay, we are talking about binary evaluation, yes or no. So all these documents, they are relevant. Okay, yes, they will be for yes. And on this left, on this right side, these are no, they are not relevant to the query. Okay, so these are the relevant documents, and on the right they are irrelevant documents. And in the middle, this is the result set. Okay, this is the result set. Now in the result set, you can see these are true positive. These are actually the relevant documents. So it returned some of, like this document, this. They are relevant and they are considered to be relevant by our algorithm. These documents, they are relevant, but they are considered to be irrelevant by our system. This is false negative. Our system says they are not relevant, but they are actually relevant. They should have been included in the result set, but actually they are not included. And over here, these documents, they should have been excluded from the results. They are not relevant. They are false positive. So our algorithm, it thinks they are positive. They are relevant, but actually they are not relevant, right? So this is the actual relevant documents, and these are returned by our algorithm, the actual, okay? And these are the documents which are relevant, but they are ignored by our algorithm. And these are the documents which are irrelevant, but they are considered to be relevant by the algorithm. So precision is the ratio of this section, okay, with the entire result set, okay, and recall is the ratio of this section with the entire relevant set. If you see, precision is the ratio of this with the result set, and recall is the ratio of these documents with the relevant set. I hope it is clear for you now. And the last thing, sometimes we merge both these measures, precision and recall, into one measure which is called F measure. So the formula for F measure is 2 over 1 over IR plus 1 over P, or you can get 2 into R into RP, P divided by R plus P. So F measure is also commonly used. We will not go into details. If you take the advanced information retrieval course, you will study in much more detail about how to calculate the effectiveness. And the last thing, if the user is interested in reading only 1 or 2 relevant documents, ranked retrieval may provide a more useful result than Boolean retrieval. Okay. So ranked retrieval, we talked about it before, that Boolean retrieval is used for experimental purpose. You have simply yes or no. In ranked retrieval, we may rank the relevance as extremely relevant up to extremely irrelevant, right? Because it's hard to say that this document is related to a query or not. It is more flexible to say that it is extremely relevant to some relevant, or not relevant, or completely irrelevant at all. Okay. Lastly, to extend our notions of recall and precision to the ordered list returned by ranked retrieval algorithm, we consider the top k documents returned by a query result from 1 to k. Okay. Sometimes we are interested only in top k documents. Okay. For example, in Google, we rarely go to the second page returned by the Google, right? We rarely go. Most of the time we are interested in only top 10 or 20 documents. So if we are interested in, let's say, top 10 or 20 documents, the value of k will be, let's say, 10 or 20. So in this case, we can measure recall or precision for the top k documents by using by considering the top k results and calculating it by using the same formula, right? So that's all for the information retrieval. Our module ends over here. We have talked about information retrieval. We discussed several applications of IR. We talked about language modeling concepts. Then we discussed the indexing concepts. We talked about the searching concepts, how to search the information, searching algorithms. We talked about the retrieval and ranking concepts, the vector space model, and finally we talked about the evaluation of IR methods. Inshallah, in the next lecture we'll move to the second module of the course and we'll continue, inshallah. Thank you very much. That's the end of the lecture. Assalamu alaikum wa rahmatullahi wa barakatuh.